Hello students, this is lecture 27 based on second unit for your subject digital signal processing. So in this lecture we are going to discuss about this new topic frequency transformation. Okay, so in previous lecture we have been discussed about this design of digital Chebyshev filters and its some examples. Now the next topic is frequency transformation. So let's start with this topic. Okay, what is this importance of this topic is frequency transformation. Okay, so whenever in most of the examples you guys have seen that we use the low pass filter, okay, the basic filter. For all of the designing we have seen low pass filters, and if we talk about this we have also high pass, band pass and band reject filters, and you want to design these filters. Okay, so what we have to do, we use the prototype as a low pass filter, then we take the help of this frequency transformation. Okay, so here I have written some points, okay, important points. These are basically related with frequency transformation. So these are basically four types of filters, as I told you: low pass, high pass, band pass and band rejects or band stop filters. In all the design techniques, that is Butterworth or Chebyshev, we read about both the designing procedure. We considered only low pass filters. Okay, so as you have seen in previous lecture, we have only taken this low pass filters. Now if a high pass or band stop or band reject, okay, filter is to be designed, then just we design prototype low pass filter and then convert this is to the desired using frequency transformation. Okay, so because we already read about this low pass filter, so it would be easy for us. Okay, so there are two types of frequency transformation. Okay, if we talk about the transformation, first one is the analog frequency transformation and second one is the digital frequency transformation. So in this if we talk about this first one, analog frequency transformation, in this analog prototype function HPS is converted into another analog system function HS, and then HZ is obtained using any transformation, whether it can be bilinear transformation or impulse invariant transformation. Okay, so HPS is converted into the analog system function HS, and when we receive this HS, we convert this HS into HZ. Okay, in digital frequency transformation, in this analog prototype filter HPS is first converted to the digital domain to get HPZ. Okay, so for in this process, not going to direct HS, firstly we convert into digital form. Okay, then using frequency transformation it can be converted into desired digital filter. Okay, so there are two methods or two type of frequency transformation: analog frequency and digital frequency. Now if we have analog frequency transformation, if we talk about, okay, and if we have low pass with cutoff frequency, that is OMC. Okay, this is the type. Okay, because we are considering the low pass. Now so low pass with cutoff frequency OMC star, then S is going to replace with this OMC upon OMC star into S. Okay, now if we want to convert this high pass with cutoff frequency ohm c star, then this S is going to replace with the ohm c into ohm c star upon S. So you have to remember this रिप्लेसमेंट ओके कि एस को हम किससे रिप्लेस कर रहे हैं ओके सो लो पास with new ohm c star cutoff frequency. If we want to convert in high pass, then S is going to replace by the ohm c into ohm c star upon S. If we have low band pass, okay, with lower cutoff frequency ohm 1 and higher cutoff frequency ohm 2, then this S is going to replace by ohm c into h square plus ohm 1 ohm 2 upon S ohm 2 minus ohm 1. Okay, and if you want to convert it into band stop with lower cutoff frequency ohm 1 and higher cutoff frequency ohm 2, then this S is going to replace with the ohm c into S ohm 2 minus ohm 1 upon S square plus ohm 1 into ohm 2. Okay, so these two are little bit same, just denominator and numerator is exchange. Okay, so now if we have one question, for example, in the question is given, transform the prototype low pass filter with the system function. So the system function Hs is given ohm c upon S plus ohm c into a high pass filter with cutoff frequency ohm c star. Okay, now we have to convert this into high pass filter. Okay, so for high pass filter we have already seen this S is going to replace with this ohm c into ohm c star upon S. So we can easily do this. The analog frequency cutoff frequency is given ohm c. Transformation में replace क्या करेंगे? S is going to replace by this ohm c into ohm c star upon S. Okay, so the transfer function is given this Hs equal to ohm c upon S plus ohm c. So this ohm c is going to be this S is going to replace by this function. So just put this value, okay, ohm c into ohm c star upon S into over here. Okay, so when you put ohm c into ohm c star upon S plus ohm c, when you solve it, so the new transfer function will be S upon S plus ohm c star. So that will be the your answer. Okay, now the next question is given, a prototype low pass filter has the system response. So system response is given, that is 1 upon S square plus 2S plus 1. Obtain a band pass filter with ohm naught equal to 2 radian per second and Q is 10, ohm naught square equal to ohm 1 into ohm 2 and Q equal to ohm naught upon ohm 2 minus ohm 1. So this data is given to you in question. Clear? So we have to find out this. Firstly, the cutoff frequency ohm c. Okay, so for calculating the ohm c, you have to compare with the standard function. Okay, so when you compare this equation Hs with the standard one, okay, so we will get this ohm c equal to 1 radian per second. Okay, so ohm c equal to 1 radian per second. Now we want to convert this band pass filter. So for band pass filter we have already seen this S is going to replace by this function, that is ohm c into S square plus ohm 1 ohm 2 upon S ohm 2 minus ohm 1. Okay, so we are going to replace using this. Okay, now ohm1, if we talk about this function, so ohm1 into ohm2 is given, that is ohm naught square, okay, and ohm naught equal to is given 2. Okay, so just put this value over here. So that will be 1. Ohm C is we already know the value of ohm C, so just put the value of ohm C as square plus ohm naught square. So ohm naught equal to is given 2, and that is 2 square, and S ohm 2 minus ohm 1. So ohm 2 minus ohm 1 we can calculate with the help of the data is given, because Q equal to 10. So just put Q equal to 10 over here. Ohm 2 is equal to 2. So we know the value of this ohm 2 minus ohm 1. Okay. So just put this value and we get this function. Okay. So now this S is going to replace by this. Okay. So when you solve this, so S is come 5S square plus 20 upon S. Clear? So just put this value in this HS. Okay, so when you put this value, we will get this new transfer function for band pass filter. Okay, so in this way we can convert into a given filter, whatever, whether it is high pass, band or band reject, with the help of the taking as a prototype low pass filter. Okay, so this is just all about your topic is frequency transformation. Okay, so thank you students.